Okay, so then consistency. So in the case of consistency, to achieve the consistency, they are using consensus algorithms, so that they ensure that all the nodes will have the same copy of data. Okay, and this blockchain technology that what we are going to study, it is again this. It is going to achieve the state machine replication. Okay, state machine replication is nothing but that is what is going to be achieved by this consensus algorithms. Okay, so now we will see what is this. So not in detail, but to some extent, some points we see about this consensus mechanism or the consensus algorithms. Okay, because in later modules we will study in detail the consensus algorithms. So, but we will now just see an introduction on what is this consensus is about. Okay, so consensus is a process of agreement between the distrusting nodes on a final state of data. So, as we have taken that example of Byzantine's general's problem, there are several commanders in the army, and there are several soldiers under them. And when they need to go and attack their enemy, all these commanders should have the same instruction. Okay, so if the army general is giving an instruction, right now we'll all go and attack, then that information should be passed on to all the commanders, and they all should agree with that message. Okay, because there may be a problem that the messenger may be a traitor, and he may give to one commander that the message is to attack, and to another, no, we should not attack. So there may be a problem. So consensus is that all the nodes. Okay, so now here nodes, we can mention, we can refer it to that each commander in different place. Okay, so this consensus process is that we should get an agreement between from the all the nodes on the final data. Okay, so now this is actually a challenge in the distributed system. When multiple nodes are participating in a distributed system and they need to agree on a single value, it becomes very difficult to achieve the consensus. So this concept of achieving the consensus between multiple nodes is known as the distributed consensus. So for that, there are actually several algorithms they are coming upon with. But what has gained much popularity is that the advent of this bitcoins and blockchain. So after this bitcoins and blockchains came into existence, this consensus becomes a mandatory property of this technology, because the blockchain is it is a distributed as well as decentralized technique. Okay, so it is both distributed as well as decentralized. So there is no central authority for this blockchain. Okay, in blockchain technology there is no central authority. In the first class I gave you the example. So if you want to do some transaction with their person, then what you will do, always you go with the third party. Okay, either through a bank or through some online mechanisms. Okay, online payments. So anyway, there will be some central authority or some third party will be present in that transaction. So you always send the transaction through some third party. Okay, so that means there is a centralized authority to monitor the transactions, and if anything goes wrong, then it will be intimated immediately. But now, in the case of this decentralized and distributed blockchain technology, there is no central authority. Okay, there is no central authority. So all the transactions will be only between the sender and the receiver. It is always only between the sender and the receiver. So that means there is no control over that transaction. It is all between you and the receiver. So in that case, when it is done on a very big network, it should be very carefully monitored, okay, or not by a single authority, but by through this consensus mechanism. All the nodes, or at least majority of the nodes in the network, have to agree on that transaction. Okay, so instead of having a single centralized authority, here the thing is, in the blockchain technology, we are having a network having so many nodes. Okay, so now when a transaction is made, all these nodes have to give agreement, okay, or they have to agree on that particular transaction. If at all not by all, at least most, okay, most of the or majority of the nodes has to agree on that transaction. So that is what is given here. A consensus mechanism is a set of steps that are taken by all or most nodes, okay, or almost majority of the nodes, in order to agree on a proposed state or value. And so this consensus mechanism, as we have discussed in the previous thing, for distributed till only distributed systems was there, it is really a big challenge. Okay, it was almost not possible to get this consensus. But when this Bitcoin and blockchain technology come into existence, now this consensus mechanisms again, they gained its popularity, and several algorithms were proposed by different people to come to a consensus. Okay, so what is the requirements of this consensus mechanism? There are five major requirements for this consensus mechanism. The first one is the agreement. Okay, the first one is agreement. Then second one is termination. The third one is validity, and the fourth one is fault tolerant, and fifth one is integrity. Okay, so these are the five things that are required for coming to a consensus. So consensus means nothing but an agreement. Okay, an agreement between all the nodes, or almost majority of the nodes in a network, on a final state of data. Okay, so they need to agree on that final transaction. Okay, so what is the meaning of the term agreement? Okay, all honest nodes decide on the same value. Okay, so now we have discussed about what is a node, and what kinds of nodes may be there. There may be honest nodes, okay, and there may be some faulty nodes. So that is not by intention, but the system might have crashed, or something might have happened. So there may be faulty nodes, and there may be Byzantine nodes. Okay, they do intentionally. So, and in the distributed system, one more thing, what we can say as an example how this consensus is very difficult is that you would have studied about your DDoS, right? Denial of attack service. Okay, so this denial of attack, how it will affect this distributed system is, so the if one of the system is keep on getting some unwanted thing that it disrupts the system, then the entire system will be it is not able to perform properly. So that is why we have seen there the fault tolerance is important. So even if one system is affected by some problem, still the network should not be disconnected. Okay, the network should not be entirely disconnected. Okay, so now so that is a problem in this distributed system. So to come to a consensus mechanism, what is needed? Okay, so first requirement is this agreement. So agreement means all the honest nodes in the network decide on the same value. Okay, so there may be honest nodes, there may be faulty nodes, and there may be Byzantine nodes. But this all the honest nodes, they should decide on the same value. Okay, don't get confused. What is this value? What is this data? What is this transaction? We will slowly look into all these things when we move on to blockchain. Okay, and the next one is termination. All honest nodes terminate execution of the consensus process and eventually reach a decision. Okay, so what is the meaning of termination here? So at some point they all should come to a agreement, or all or majority of the nodes in the network. That means all the honest nodes in the network, they should come to an agreement. Okay, this is the final data, and this data, because we see that whenever some updation has happened or whenever some transaction has happened, that has to be available in all the nodes of the network. Okay, it should be available in all the nodes of the network. So that is what the availability property. So now here they should all come to a agreement that this is the final thing, and they terminate that execution. Okay, so they come to a decision. Okay, this is the final data, and they terminate that consensus process. Okay, and the third one is the validity. So the value agreed upon by all the honest nodes must be the same as the initial value proposed by at least one honest node. So here they need to again validate the data. So what is validation? So they all have to agree based on the initial value proposed by the one of the honest node. So the transaction must have been initiated by one honest node in the network. Okay, so now they need to agree, all the nodes or at least all the honest nodes, they need to agree upon that data, or they need to validate that data which is initially proposed by the honest node. Okay, so the validity is important before coming to an consensus. So first thing what we have seen, first one is agreement. They all should agree on the same value. Then termination. So once they reach a decision, they should terminate the process and they should validate the value that is agreed by all the nodes. And the fourth requirement is the fault tolerant. Okay, the fault tolerant, what it says, the consensus algorithm should be able to run in the presence of faulty or malicious nodes, or we can call it as Byzantine nodes. So what it is telling, so there may be some faulty nodes or there may be some malicious or Byzantine nodes in the network that we cannot avoid. Okay, because we cannot trust every node in the network. There may be some malicious or faulty nodes that definitely it will be available in the network. But still, because of those one or two malicious nodes, the system should not break. Okay, the system should not it should not work improperly. Okay, so that is what the consensus algorithms requirement. Even if there are some malicious nodes available in the network trying to disrupt the system or trying to give wrong information or to input some wrong data into the network, apart from all these nodes, the consensus algorithm should be able to run properly in the network. Okay, so that is why actually we are always saying that almost, okay, not all the nodes in the network, it is not possible, not all the, because these Byzantine nodes will not agree with that data, because they are trying to give their own faulty data. Okay, so this will not agree with that. But what we need is, we want to have the agreement of majority of the nodes, or we can say from all the honest nodes we need to have the agreement. Okay, and then comes the last point, that is integrity. So the nodes make decisions only once in a single consensus cycle. So that means the honest nodes, they are doing the they are all agreeing upon a final value. Okay, so in that case, this decision has to be made only once. Okay, so they cannot simply change their decision as and when they like. Okay, so only when they agree on a single final value in a and the decision has to be made at a single time, So then we can call that the data has some integrity. Okay, so that is the concept of integrity. So all these 5 are the requirements for the having a consensus mechanism. So when we are having all these 5 requirements satisfied, then we can say that that particular network has come to a consensus on a particular transaction. Okay. So there are some 2 types of consensus mechanism. These are all mechanisms, okay, and we will study different algorithms later. The 2 types of consensus mechanism where the either they can be Byzantine fault tolerance based on, and the second one is leader based consensus mechanism. Okay, the first one is Byzantine fault tolerance based, and the second one is leader based consensus mechanism. So the first one, that is Byzantine fault tolerance based. Okay. So here what it is said is, so they need to what they are telling is here, the nodes or the processes are named replicas, and consensus is achieved in the presence of faulty nodes by agreement among a majority of nodes. So this is what we have discussed in the previous slides also. So that they are giving the name as Byzantine fault tolerance based. Okay, so when the majority of nodes or all the harnessed nodes in the network, they come to a when they agree on a particular data, okay, then they will be able to say that this transaction can be accepted, and so this is the final data, and they will come to an agreement. Okay, so this happens without much intensive operations. Okay, there is no need of much computations or operations, but just because that they have received majority number of messages. Okay, when a certain number of messages are received, then an agreement is reached. So that means from all the harnessed nodes, if all the harnessed nodes come to an agreement on a particular final data, then the consensus will be come to a point. Okay, so that is Byzantine fault tolerance based. One second, I'll give some data. Actually, there is one practical implementation on this thing that is called as Paxos. I have not put it in the PPT. I'll just tell you. So that is known as Paxos. Okay. So this is actually introduced in 1989 by a person called Leslie Lamport. Now, in what this system, what is this practical implementation is about is, here there are, for each node they will assign some different roles. Okay, the roles may be some proposer, acceptor, learner. Okay, so different roles were given to the nodes present in the network. Now here, when majority of this, as we have seen here, when majority of these roles or the nodes, they agree upon a certain thing or a certain final value, then they came to an agreement. Now another type of mechanism, or another type of consensus mechanism, what we are seeing here is leader based consensus mechanisms. Okay, leader based consensus mechanisms. So what is this leader based consensus is that among all the nodes present in the network, a leader will be elected. Okay, so you know what a leader is, right? So among a group, in a class of 60 students, we elect a leader. So similarly, when there are multiple nodes in the network, a leader is elected, and all the other nodes should follow this leader. So what happens here also, Like the previous system that was implemented named as Paxos, another kind of system or the implementation they have brought in is Raft. Okay, RAFT, Raft. So this Raft system, in this system, similar to the previous one, here also we have certain roles for the nodes. Okay, like follower node, candidate node, leader node. Okay, so there are different roles given. So there will be one leader elected among the nodes, and how this leader will be elected is if that particular node gets enough vote. Okay, it is like how we select our leaders. Okay, we vote for different leaders, and whoever gets the maximum number of votes, they will be chosen as the leader. Okay, similar concept. So there are several nodes available and in the network, and there may be few nodes that will be opting for a leader node. So if a particular node gets maximum number of votes or enough number of votes for, then that will be elected as a leader. And what now happens is, now it is the responsibility of that leader node who has to commit the changes. Okay, like you would have studied in your DBMS, right? Um, like two-phase commit protocol and all you would have studied. So what happened there? What is the meaning of commit? So once it is commit, the changes done or it is accepted. Okay, it is committed. Then it will not be changed. So for that you go for two-phase commit protocol, right? So in the first phase, everyone will share that thing, and it will be you prepare the things. Okay, and in the second phase only you commit the data. Similarly here also it is similar to that. So now you elect a leader node which will actually receive enough messages, or it will be having the enough number of votes to become a leader. So now this leader will commit the changes that happen in the network. Okay, whatever the transactions is done, the final data that has to be committed. Okay, now this is the final value everyone can agree upon. Okay, so that decision will be made by the leader node. So now once the leader node commits the changes that was proposed in the network, then that will be replicated among all its follower nodes. Okay, so in the Raft system, what is happening? There are some different roles given to the nodes, like follower, candidate, and the leader. Okay, so this leader based consensus mechanism, what is consensus? They need to come to an agreement, right? They need to come to an agreement for a final value of data. So for that they choose a, or they elect a leader node. So once a node is selected as a leader, then all the other follower nodes will be agreeing upon the same value. Okay, so now the leader will be committing the proposed changes, and that will be replicated to all the majority of follower nodes. Okay, so these are the two different types of consensus mechanisms. um, is there any doubt in this? One second, I'll share the another. Okay, we'll see some terms in this blockchain technology quickly. Are you able to see moving of slides?
No, ma'am. No, ma'am.
Now is it moving?
Yes, ma'am.
Yes. Okay, so these are some terms we are going to use in the Bitcoin. See, you need to understand very clearly that Bitcoin is the implementation of blockchain technology. Okay, Bitcoin is one of the implementation or application of the blockchain technology. Okay, so in general, blockchain technology can be applied for different applications. So one such application is Bitcoin, but we can say it in another order also. Only when this Bitcoin comes into existence, the blockchain technology has grown into a very big technology. Okay, so but still Bitcoin is one of the application or implementation of blockchain technology. So we see some of the terms in this Bitcoin or the blockchain technology. So one of the thing is transaction. So even in the previous slides when we discussed, I often told you about the transaction. So when a transaction happens, all the nodes in the network should agree upon that transaction. So a transaction is a fundamental building block of the Bitcoin blockchain. And it is the operation in which we transfer value from one party to another in a secure way. So as I told you earlier, in this blockchain or in this Bitcoin thing, we are going to do the transfer of value, or we are going to do the transaction between it is going to happen only between the sender and receiver. Okay, there is no central authority. It is going to absolutely happen between the sender and the receiver. So now this Bitcoin, as it follows the blockchain technology, it is a decentralized trust system. Okay, so here some of the things were displayed. This QR code you are very much familiar, right? So now what you will do usually when you go to a shop, even for a coffee shop, you will get a cup of coffee, and using your PayPal or some other thing, you will pay the money. Okay, there will be a QR code given there, and you will just scan it and pay your money and come back, right? So now here, now even this kind for our normal money that we are using in the Indian rupees or dollars, we have already that system. But even for Bitcoin also, even for such a small transaction, okay, the Bitcoin's value is very, very high. Okay, the I do not know the present value. I'll check it and tell you in the next class. And even you can check that. Okay, but the value of Bitcoin has grown up very large. But even in that case, we'll be able to do a very small transaction like this. Okay, a retail transaction. That is what they are trying to say here. Even for buying a cup of coffee also, we will be able to do such Bitcoin payments. Okay. So what happens is when a transaction happens. Okay, so now what Alice is in the previous example, you can see buying a cup of coffee from Bob's coffee shop. Okay, Alice is buying the coffee from Bob's coffee shop. So now this is a transaction. Okay, so now this transaction. So what Alice will do? Alice will pay her amount for that coffee in that point of sale system, okay, using the Bitcoin. and so this is a transaction, okay, a transaction made between Alice and Bob. So now this transaction, it is bundled as a block, okay, and so such several other transactions would have happened along with those transactions. This transaction that is made by Alice is also bundled, and it is put it into a block. Now this block will be broadcasted to all the mining nodes in the network, okay. In the later classes we will see what those mining nodes. So in the network there are several nodes, and it will be it is broadcasted to all the nodes in the network. So that is what we have seen. All the nodes in the network should come upon an agreement on this particular transaction that is made. So how this blockchains work? So first a transaction is requested, okay, and second it will be created as a block, okay, a block that represents the transaction is created, and now this block will be sent to every node in the network. You could see in the picture. So the block will be sent to every node in the network. So now the nodes have to validate the transaction. In the consensus mechanisms requirement, we have seen one point as validity, okay. So all the nodes have to validate the transaction. So we will see how this validation will be done, okay. That is where we have the proof of work algorithm and all those consensus algorithms that we will study later. But as a general flow, we will see this, okay. So after validating, so among the different nodes in the network, the node which is doing the validation first will receive the award, okay, or the reward. So it will receive a reward for the proof of work, okay. That means what is meaning of proof of work? It validates that the transaction is right, and it could be followed by all the other nodes in the network too. So once it is validated, that block will be added to the existing blockchain. So the blockchain is nothing but it is a list of blocks, okay, and it is a chain of blocks that is connected together. Once the transactions that is present in the block is validated, it will be added to the blockchain. So once it is added to the blockchain, that transaction is complete and it cannot be tampered by anyone, okay. And we will see why it is so secure, because it is very costly, okay. This validation process, it is a very costly process, and we will see how that works in the other class, that when we study that particular topic, okay. So this is how these blockchains work, and how the transactions will created, and how they are converted into a block, and how these blocks are transferred to all the network, all the nodes in the network, and how each of the nodes try to validate that transaction, and once it is validated, it will be added to the blockchain, okay. So with this we'll stop today's session, and we will continue with the next class. So So kindly give me the attendance, and once you give the attendance, you can leave the classroom, okay. Unmute your mic and quickly give, and once you give, you can leave the class. 38, Neela Sumant.
Present, ma'am.
Jomin Jose.
Present, ma'am.
Manoj Preetham. Jerome Andrew. Nelson Darius.
Present, ma'am.
Gemini Annie.
Present, ma'am.
Gemini is there? Yes.
Present, ma'am.
Sheshandri. Yes.
Present.
Sheshandri. Annie Cruz.
Present, ma'am.
Mukesh. Venkata
Yes,
Mukesh.
Present.
Naveen Kumar.
Yes, ma'am.
Satish Kumar Reddy. Preetham, Jaladi Preetham 1001.
Present, ma'am.
Benzam Raj,
Present, ma'am.
Angeline Subagar,
Present, ma'am.
Ujjal,
Present, ma'am.
Lasvita,
Present, ma'am.
Joel Sam. Joel Sam is there.
Present, ma'am.
Steve Abraham, Aditya,
Present, ma'am.
Bevin Jeff,
Present, ma'am.
Soumya,
Present, ma'am.
Adina,
Present, ma'am.
Joseph Rajan,
Present, ma'am.
1015 present. Karen Beulah,
Present, ma'am.
Divina,
Present, ma'am.
Alex Kuriakos,
Present, ma'am.
Bharat,
Present, ma'am.
Ashish Kumar, Emmanuel Raja,
Present, ma'am.
Jabez Samuel,
Present, ma'am.
Sam Jonathan,
Present, ma'am.
Vigneshwar,
Present, ma'am.
Chinmohan Lal,
Yes, ma'am.
Letitia,
Present, ma'am.
Christina,
Present, ma'am.
Ashley John,
Present, ma'am.
Hayden Rex,
Yes, ma'am.
Sriram Prasad,
Present, ma'am.
Jemima Elizabeth,
Present, ma'am.
Harsha Anna,
Present, ma'am.
Rajat Nair,
Present, ma'am.
Rishabh Nair,
Present, ma'am.
Manoj Abraham,
Present, ma'am.
Bibia Susan,
Present, ma'am.
GB Thomas,
Present, ma'am.
Selva Mabisha,
Yes, ma'am.
Abhilash,
Present, ma'am.
Don Milton, Janovan,
Present, ma'am.
Darwin,
Present, ma'am.
Lamik,
Ma'am.
Maria Santosh,
Present, ma'am.
Sasidhar Reddy,
Present, ma'am.
Austin,
Present, ma'am.
Sanjay Ratna,
Present, ma'am.
Kevin Paulson, Sri Sai Rahul Reddy,
Present, ma'am.
Naveen, sorry, Kavin,
Present, ma'am.
Singham Shetty,
Present, ma'am.
Sriram.
Present, ma'am.
Okay, the absentees were URK 18 CS 119, 180, 272,
119 present.
119 present free come.
Yes,
Okay.
ma'am. Yes, ma'am.
180 is there, Jerome. 272 absent, 1040, 1149, 11213.
Ma'am, 1080, you didn't call my name, ma'am.
1080, 180.
Ma'am,
URK
10.
18.
Yesterday only I paid the fee, ma'am.
Okay, 1080. Yeah, I have called your name, right? Sriram Prasad.
Oh, ma'am. Okay, ma'am.
Yeah. Yeah, I have marked you present.
Okay, ma'am.
Ma'am.
Yes.
Ma'am, you didn't call 1003, ma'am. Shnoy. 1003, ma'am.
But it is not shown in my reserve.
Okay, ma'am. Then I will talk to
You
my
check
mentor.
with your mentor and reserve coordinator, right?
Okay, ma'am.
Okay, ma'am. Okay, thank you, students. You can leave the
Ma'am?
class. Yes.
GCR class code, ma'am.
GCR class code. 1 second. I have given the class code in the chat box. Note it down. Okay. மேம் இப்பதான் ஃபர்ஸ்ட் வர ஒரு கலைபுரத்துல முடிச்சிருக்கேன் நானு. அப்படியா மேம்? அன்னைக்கு முடிச்சிட்டீங்களா மேம்? அன்னைக்கு அந்த பிபிடில உள்ளது வரைக்கும் முடிச்சிட்டீங்களா கிராமர் எல்லாம்? செகண்ட் பிபிடில மேம் அன்னைக்கு ஒரு பெரிய கொடுமை நடந்துச்சு மேம். ஒருத்தன் எவனோ வந்து இடையில தான் ஜாயின் பண்ணான். சரி நானும் வந்து கொடுத்துட்டேன், இல்ல அலோ பண்ணி விட்டுட்டேன். சரி அவன் பாவம் நடுவில் ஃபீஸ் கட்டி வந்திருப்பான் ஏதோ வந்துட்டு விட்டுட்டேன் நான். அவன் அப்புறம் கடைசி வரைக்கும் வெயிட் பண்ணிட்டு, மேம் இது இங்கிலீஷ் கிளாஸா மேக்ஸ் கிளாஸா அப்படின்னா பாருங்க எனக்கு. ஏன்னா இது ஃபுல்லாவே அப்படிதான் நடத்திட்டு இருந்தோம்ப்பா. கிராமருக்கு எக்ஸாம்பிள் மட்டும் அந்த நம்ம நார்மல் நவுனு ப்ரெடிகேட் வச்சு சொல்லிட்டு இருந்தேன். அதுக்கு முன்னாடி ஒரே ஆல்பபெட் இதுன்னு மேக்ஸ் தான் சொல்லிட்டு இருந்தேன்னா சிக்மா ஸ்டார் சிக்மா பிளஸ்ன்ட்டு அவன் ரொம்ப குழம்பி போய் மேம் இது என்ன கிளாஸ் மேம்? அடப்பாவே, அது பரவாயில்லையே. இந்த மாதிரி அவன் கடைசி வரைக்கும் வெயிட் பண்ணி வேற இந்த மாதிரி கேட்டு போனோம், தம்பி இது தியரி ஆஃப் கம்ப்யூட்டேஷன் கிளாஸ், இதுல வந்து இனிஷியலா இதெல்லாம் வரும் அப்படின்னு சொல்லி இந்த மாதிரி ஒரு எல்லாருமே தியரி சப்ஜெக்ட்னு சொன்னானம்மா. அதையும் மீறி இது இங்கிலீஷ் கிளாஸ்ன்ற நிலைமைக்கு ஆயிட்டேன். நான் இது வரைக்கும் இப்படி ஒரு கொஸ்டின் நான் வந்து டிஎஸ்சி கிளாஸ்ல வந்து பார்த்ததே இல்லை. சரி இன்னைக்கு என்ன எடுக்க போறீங்க? நானும் அதோட தான் முடிச்சிருக்கேன். அப்ப நீங்களும் நானும் ஒரே ஃபேஸ்ல தான் போறோம். ஏன்னா அவனுக்கு வந்து சிக்மா. வாட் அ கிரேட் நியூஸ். எனக்கு அது வேற ஒரே பயம், இன்னைக்கு என்னடா இவங்களாம் எங்கேயோ டிஎஃப்ஏ என்னவேன்னு போயிட போறாங்க. ஏன்னா எனக்கு வந்து அவனுக்கு ஃபர்ஸ்ட் புரியவே இல்லை மேம். இந்த சிக்மா ஸ்டார் சிக்மா பிளஸே எனக்கு புரியல. எனக்கு வேற எழுதி கொடுக்கறதுக்கு வேற வழி இல்லையா, அதனால வந்து அப்புறம் திருப்பி எக்ஸ்பிளைன் பண்ணி தான் அவனை விளங்க வச்சேன். அதனால என்னால முடிக்க முடியல இது வரைக்கும். மெம்பர்ஷிப் கிராமர்னு ஆரம்பிச்சு இந்த இங்கிலீஷ் கிராமரோட முடிச்சதுனாலதான் பையனுக்கு அப்படி ஒரு டவுட் வந்துருச்சு. இப்ப இனிதான் வந்து இன்னைக்குதான் நான் ஃபார்மல் டெஃபினிஷன் போறேன் கிராமருக்கு. ஓகே, அப்ப இது முடிச்சு இதானா இது எவ்வளவு நேரம் போகும் தெரியல. இது முடிச்ச பிறகு என்ன ஆரம்பிப்பீங்க? போகாது, ஆமா முடிஞ்சிரும் இது சொல்லிட்டு. என்னன்னு வேணா ஒரு இது கொடுத்துக்கலாமா? அடுத்த ஏன்னா அதுதான் இருக்குது, ப்ரொடக்ஷன் அண்ட் டெரிவேஷன். ஓ இது இன்ட்ரோடக்ஷன் 1 மாடியூலே அதுதான் இருக்குதா கிராமர்ஸ்? ஓ ப்ரொடக்ஷன்ஸ் அண்ட் டெரிவேஷன். அப்ப அந்த ப்ரொடக்ஷன் அண்ட் டெரிவேஷன்ங்கிறது இந்த கிராமர் எக்ஸாம்பிள் சொல்லும் போதே முடிஞ்சிரும்ல. ஓகே, ஓ சரி. அடுத்து சாம்ஸ்கி ஹைரார்கி. ஓகே. ஓ சரி, அப்ப பாப்போம். அப்ப வேணா ஏதாச்சும் ஒரு 2 ப்ராப்ளம் வேணா கொடுத்து நீ ஏதாவது டெரிவேஷன் சும்மா சின்னது பண்றதுக்கு வேணா சொல்லலாம், அது வேணா சொல்லலாம். ஓகே சரி சரி. அப்ப இப்போதைக்கு அடுத்த மாடியூல் ஆரம்பிக்க மாட்டீங்களா? ரெகுலர் எக்ஸ்பிரஷன் லாங்குவேஜ் அது இதுன்ட்டு இருந்துச்சுன்னா தொடங்கலாம். சும்மா ஒரு டெஃபினேஷன் மட்டும் வேணா கொடுக்கலாம். டிஎஃப்னா என்ன அப்படின்னு சொல்லி ஒரு டெஃபினேஷன் வேணா கொடுத்துட்டு ஆரம்பிக்கலாம். சரி ஓகே. ஆனா நம்ம இதுபடி வந்து ரெகுலர் எக்ஸ்பிரஷன் தானே ஃபர்ஸ்ட் நடத்தணும்னு சொல்லியிருந்தாங்க. ஆமா, ஏன்னா இப்ப மாடியூல் 2ல பாருங்க ரெகுலர் எக்ஸ்பிரஷன்ஸ் அண்ட் லாங்குவேஜஸ் அப்புறம் தான் டிஎஃப்ஏ. அன்னைக்கு மேம் சொல்லும் போதும் அப்படி ஏதோ சொன்னாங்கல்ல, ரெகுலர் எக்ஸ்பிரஷன் ஃபர்ஸ்ட் நடத்திட்டு அதுக்கப்புறமா டிஎஃப்ஏ அப்புறமா என்எஃப்ஏ அப்படி ஏதோ சொன்னாங்கல்ல. ஆமா. ஆமா, நான் இப்ப இதை திறந்து வச்சிருக்கேன். சரி, அப்படி டைம் இருந்துச்சுன்னா ரெகுலர் எக்ஸ்பிரஷன் என்னன்னு வேணா சொல்லலாம். மற்றபடி இதுக்கே டைம் ஆயிரும் தான் நினைக்கிறேன். அவனுக்கு ஒரு 2 கேமரா கொடுத்து சும்மா டெரைவ் பண்ணு கொஞ்சம் அவனுக்கு பண்ண வச்சோம்னா சரியாயிரும். டைம் ஆயிரும். ஆமா. ஏன்னா அப்புறம் டிஎஃப்ஏ தொடங்கி விட்டுட்டோம்னா அப்புறம் முடிக்க முடியாது. ஏன்னா டிஎஃப்ஏ அவங்க கணக்குப்படி பின்னாடி தான் வருது. ரெகுலர் எக்ஸ்பிரஷன் என்எஃப்ஏ ஈக்குவலன்ஸ் வித் ரெகுலர் எக்ஸ்பிரஷன் அப்புறம் தான் டிஎஃப்ஏவே ஆரம்பிக்கிறாங்க. ஸோ நம்ம இந்த ஃப்ளோலயே போவோம். ஓகே மேம். ஓகே மேம். ஓகே, தேங்க்யூ மேம். தேங்க்யூ. பாய் மேம். பாய். Hello. Hello. Yes. Yes, 1015. I have given you attendance, ma'am. Which saw it in the chat box and I have given. Okay. 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 If that's the case, you just put in the chat box. I'll check that. Yeah. Okay. 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 Yes. 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 Okay. Okay. Thank you.